Thanks, Barry. My name is Alexander May, and I'm the Technical Manager with Sircel. So we're an Australian-owned and operated green technology business, and today I'm going to speak with you about our experience in recycling e-waste and specifically solar panels, and within that, the broad waste category of e-waste. So we'll be looking at the problems and the challenges, but also the huge opportunities that we face. So Sircel is a green technology company, and we're solving the rapidly escalating global e-waste crisis here in Australia. With our world-leading end-to-end process, we're able to divert up to 100%, depending on the product, of end-of-life electronics away from landfill and extracting the source materials within those, such as the valuable metals that should be reused and drawn back into the circular economy. E-waste means everything from that has a plug and battery, from consumer items such as telephones, civic infrastructure, through to solar panels, everything in between. Over the last 8 years, Sircel have pioneered a unique process that is ethical, it's sustainable, benefits both our business, the communities around us, and the planet. We traverse between the waste sector, manufacturing, mining, pulling all these concepts together to be in our own category of one. And within that, we see we're different to our competitors and the way that they act, and look at that, which brings its own equal opportunities. And I want to share these with you today. So last year we commissioned a new solar panel processing plant in Parkes, New South Wales, and this was made possible thanks to the funding from the New South Wales EPA with their Circular Solar Phase 2 grants program. And Australia currently, it's facing a tidal wave of end-of-life solar panels. It's really starting this year with a lot of the funded panels that have been put on 15 years ago. It's really starting to drive up the amount that we're seeing. So I've got a quick video here that'll give you an understanding of what we're doing at our Parkes site, where we've installed the primary capabilities that we have.
Sircel has launched a world-class solar panel recycling facility to give end-of-life solar panels a new future. Located in Parkes, New South Wales, our new facility is the only one of its kind in the Southern Hemisphere. We're achieving market-leading recovery rates of valuable materials. We deframe, delaminate and process each panel with our world-leading technology. We recover valuable materials that are redirected back into the circular economy. These recycled materials can find a new life in manufacturing, construction and community infrastructure. Sircel. Better for business, better for community and the planet.
So I wanted to share that with you just so you could understand how that equipment works, bringing a nice piece of glass and the cell sheets. So Sircel, we see that we're perfectly positioned to manage the pending influx of solar panels and e-waste, thanks to our unique process and equipment and our national scale, having facilities all across the country, primarily on the east coast. And currently we've got 4 locations which have mechanical recycling equipment with a diversion rate of up to 100% from landfill, depending on what's going through there. So we're really driving that link between the product and moving the materials back into the circular economy with that approach. We've built a team of experts and bringing together different industries to really excel in what we're doing with that. About 12 months ago, there was only one location on this map, and as you can see, we've really expanded that and addressed some of the challenges with e-waste and solar panels in doing so, in having multiple facilities. So I wanted to touch on the e-waste problem that we are facing, and that's generation statistics, which should blow your mind. So 22 kilograms per person will be produced this year in Australia, and by 2030, that's 657,000 tonnes per year. So for solar panels, what does that look like? This year, we're looking at 2 million end-of-life solar panels, and currently there's about 120 million solar panels installed in Australia alone. So 2 million solar panels come end of life this year. That's about 40,000 tonnes. By 2030, we're expecting that to be 90,000 tonnes. So huge amounts of rapid increase over that time, and it's just exponentially growing. So we are the largest e-waste processor by capability in Australia, and one of our locations can do 20,000 tonnes per annum. However, if we're operating at full capacity at each of our 4 processing sites, that's only 80,000 tonnes, or just over 10% of the problem that we can fulfil. But what about solar panels and that waste stream? So at our solar panel recycling facility in Parkes, that processing line that you just saw can do 1 panel per minute. And that's about 10,000 panels per month, or 2,500 tonnes per year. So when you crunch the numbers, Australia's producing 13,500 panels per day this year. So it's huge amounts that we can't even meet, and we're only going to be doing about 6%. If we stay with our current capability, then by 2030, that's only 2.5% of the end-of-life panels. So currently, what's happening with the rest of them? More than 50% of Australia's e-waste ends up in landfill, and of the 46% that is sent for recycling, the federal government reports that's less than a third that is adequately recycled. The statistics for solar panels are far worse, with only 15% of solar panels being recycled. Of the 300,000 of the 2 million are recycled adequately. We've got the word recycled in parentheses because that really is recycling, of what people call it when they're pulling off the aluminium frame and ditching the rest into landfill. We don't see that as recycling. It's not responsible, and it's a cherry-picked figure. So what we are about is ensuring that as much of the materials are returned to the highest value as possible. And pulling off the aluminium frames, it's quite easy to do, and so there's a number of players in Australia and overseas that will do this because they can achieve up to 45% of the value just by pulling off the aluminium. So it's a real easy way to drive and get that value out of the product. And the rest just being landfill. So the other components to solar panels is that they do have silver in them, they do have copper, but you can only really get access and attractive value out of those is once you remove that glass. And that's part of what that equipment at Parkes does so well. In removing that glass, creating a cell sheet that has a high silver content. So Sircel's commitment to simply be better, it drives us to find solutions to these challenges. Our impact in recycling is not just diverting from landfill, but in reducing mining of metals like copper, aluminium, silver, which all face forecast shortages in the not too distant future. And by recycling, we know that we're providing green materials, and these significantly reduce the carbon emissions compared to primary production activities such as mining. We call ourselves a green technology company, and what that means is we act and think like one. Recycling, it's part of what we do, and recycling solar panels, it's our expertise and specialisation. And our commitment to that, it goes broader. We're trying to reshape the sector in terms of the reporting components, ensuring that there's transparency, and truly leading that circular economy approach from products through to materials for manufacturing. So as you saw in that video, our hot knife separation equipment, which is installed at Parkes, and what it actually does is it uses a hot knife basically to peel away the back sheet of the solar panels after it's been deframed, which gives us a really clean aluminium, gives us a clean fraction of glass and the cell sheet, which means that we can recycle up to more than 90% of the value of the solar panels. And that equipment, it's the only one in the Southern Hemisphere, and the component about it is that it can only do monofacial undamaged solar panels. So here's a solar panel, it's monofacial, it's got glass just on one side. That machine can process it as long as it's not cracked. So with that, we try to get the message across to our customers that please ensure that you don't damage the panels, don't drop them off roofs, handle them with care, because it means a lot more to us because we can get a better recycling outcome. And for that, we offer a discount on undamaged panels as opposed to damaged panels. There's also bifacial panels, which have glass on both sides, and they are also a different challenge in themselves. So what we do with the damaged and the bifacial panels is currently we have a shred and screen process, shredding them down to this, sending them for smelting refining processes so that they can still recover the copper and silver. With that, we do provide a glassy mix, which can then go into construction materials like road base. But we know that that's not the best solution. It's downcycling. We would love to get solutions that bring all components of the solar panel, or as much as possible, back to that high quality, high purity materials that really elevates the value. So in the last 4 years, bifacials, they've really expanded presence in the market. They're more than 50% of sales in Australia now, and they were only introduced in the last 5 years. So you can see that there's a huge expansion on them. Currently, we are seeing primarily the monofacials come through, but that's quickly going to change, and we're going to have answers for both these challenges. We've looked at processes such as grinding. Grinding is suitable for the monofacials where you can take the thick glass off, but those bifacials, you're going from 4 millimeters down to 2 millimeters and 2 millimeters on both sides. So it's not an application that is suitable for that. We've looked at pyrolysis, and there is some guys in the world that are doing some great work on pyrolysis, but it is new, it has struggles with throughput, and we're still not sold that that's the best solution. So we are working with a number of academic institutions to try and develop the best solution. Something that whether it can fit all types of panels is to be determined, or whether we need to have different types of technologies for different panels is still to be determined. So what does this all matter, I guess, to everyone out in society? And the component is that we cannot continue with less than best recycling practices of e-waste and solar panels. So in January this year, there were significant changes and updates to the International Basel Convention, and now it limits the international movement of hazardous materials, with end-of-life solar panels coming into that, and also e-waste. Australia now has significant responsibility to actively prevent harm to the environment, the human health, ensuring transport, disposal, recovery of materials like obsolete solar panels. And this means a welcomed end to unethical solar panel recycling practices here in Australia. So to bring this closer to home, the Australian government has been working on a scheme to manage end-of-life solar panels. We suspect that all states will soon implement a ban on sending solar panels to landfill, and we welcome that, as well as e-waste. Ensuring panels are recycled onshore, it makes us responsible for the sustainable end-of-life management, and it supports Australia's commitment to environmental stewardship. We're actively working with both federal and state governments and to inform the legislation that support that Basel Convention implementation. And a scheme to support all players in the industry, including our customers, councils, has been drafted, and it sees a levy placed on all solar panel sales in Australia, which will then go into facilitating recycling and transport of solar panels back to for the best outcome. So what are the challenges with solar panel recycling? I went through some of the technical aspects, but for recycling of solar panels and e-waste, however, the major challenges are as a result of primarily our expanse. So to give you an understanding, freight is by far our most significant cost, with it being 40% in our recycling operations, and that is to get the feedstock to us and then supplying the materials to our end customers. So we've got this facility that's in Parks. It's quite a central location. We need to get the materials there. And so we're going to need to manage that. We have to have places, different sites, and then with that, if we could have a capability at all these different locations, that would reduce the freight, but then we still have to deal with getting the materials to our end customers. And with that, local manufacturing in Australia, it's quite limited with the offtakes of these materials. To give you an idea, 95% of scrap aluminium is exported and for reuse. So the other component for solar panels is glass. 65% of the solar panel is glass, and recently Australia's only flat glass producer closed down, which we began engagement with, and we're really disappointed to see that leave Australia capability. So this highlights our need for international material solutions, whilst efforts are also placed into rebuilding local manufacturing. The challenges are real, but the opportunities are great when handled professionally. We need to all come together to bring the focus away from singular linear issues into a more holistic view of circularity for e-waste. It's time that we drive change. It's time to act to take a sector view. We are constantly enhancing our capabilities, installing new capital equipment to process all types of solar panels, and increasing our operational capacity. What's more, we have an active advocacy arm at Sircel, which is responsible for government, industry and stakeholder engagement. Our industry engagement efforts focus on these three key principles, and that is electronic e-waste. It should be treated as its own discrete category, no longer rolled up in just waste. It's end-of-life electronics. They contain the largest range of materials by far of any waste stream. There's more than 30 elements in your phone in particular. And so that's why it's important that those materials can, and they should, be returned back into the circular economy. The recycling of solar panels, it should be supported by a new scheme and drives the best-in-class outcomes for all. And we should see that a nationally consistent legislation for e-waste management and solar is provide a consistent operating framework nationally, ensuring that there's accreditation advocacy to ensure the minimum objectives and standards for e-waste treatment and diversion of landfill. We need to look at an e-waste to e-resources strategic pathway that considers the whole problem and looks at identifying the barriers, the action plans to address them, to enable a truly circular economy with previous resources locked up in e-waste being liberated and directed back into manufacturing. End-of-life electronics and solar panels, they're not waste, they're huge opportunities. And the technology for processing, it does exist. There is still work to be done, but we know that with the support of government, this is the type of thing that they should be looking to fund and driving the innovation in. Sorry. I want to just take a step back looking at e-waste, and in particular the amounts that are produced per year. So a UN report states 62 million tonnes were produced in 2022. And our report shows that about 13% of WEEE is copper. So about 8 million tonnes of copper was produced in 2022 and likely been sent to landfill. So with the copper price at about $10,000 USD per tonne, that's a potential of $80 billion per year. And with virgin mining, there was about 20 million tonnes produced in 2022, so that's 38% that's likely going through to landfill. So it's time to act on this. It's time to do better. Thank you.